All right, so yesterday we finished up with question E, number 6. Today we're going to move on to 7, and I know we had internet issues and this and that, so this probably won't be posted until this afternoon, until I get home, unless the internet comes up. Anyway, if you're watching this, we're just going to finish question 7. So for each probability, interpret the statement. What is the probability that you test negative, given that you have or has TB? Well, you've got to go back and look at your first tree and your second tree diagram. All right, so if we look at those, all right, and I know you can't see them, but you should be able to look at them on your paper right now. You can't see them on the board over here, but if you look at the probability, we tested negative, okay? So there was testing positive and testing negative. That's out of tree number 2, and you have TB. So it goes back and says, has TB, doesn't have TB. Remember that has TB we get from tree number 1, so that's 380 people. And if you test negative, we can get that from tree number 1 also, that's 19. And it wants us to interpret the results. Well, this 19 out of 380, that's a very small number compared to the entire population. That's only 0.5%, not 5%, 0.5%. So if I'm going to write that out, and I'll do this in a different color here, just so we have the contrast of what's there. That means you only have a 0.5% chance, or there is a 5% chance of testing negative if they have TB. And you need to make sure you interpret the results. If I don't see interpretations of the results, I'm just going to dock you points. Right? What's the next one? Part B. It says the probability of that has TB given you tested negative. Okay, again, so go back to your testing. Is it has it, doesn't have it, test positive, test negative? This test negative is out of tree number 2. So I'm going to go with that number, all right? And test negative is 577. And it says has TB. So you look at 577, right? Let me just grab this and put this over here. All right? If you're looking at this, here's your tree, okay? Test it negative, because that's what the denominator is going to be. Test negative and has TB. Which branch is that? That's 19. And if we do the percent, this is 0.3%. So again, it's a small percentage. And you can go ahead and say, and we probably should do our due diligence and do the best we can to write in a complete sentence. But again, this is not English class. There is a 0.3% chance of having a positive test, okay, has TB, test negative. There's a 0.3% chance of having a positive test if the patient tests negative. All right? And then you do need to answer questions 8, 9, and 10. Part of understanding the world around us is being able to analyze data and explain it to others. So, being able to, and I know Mr. Capps is talking, and yeah, I'm talking over him because I don't really care what he's saying right now. This is the second time he's interrupted me. But based on the probability statements that could be made from either tree diagram that you would say as a friend regarding the validity of their test results, if they are testing for TB using a skin test, the result can come back positive. There is a small chance, right? So based on the probability statements that could, let me just read this again, all right? I'm not going to pause it and re-record it because I've gotten through so much already. Based on the probability statements that could be made from either tree diagram, what would you say to a friend regarding the validity of the results if they are testing for TB using a skin test and the result came back positive? Okay? Well, now we're looking at a positive versus negative result. So it's asking us, hey, what if their test result came back positive? Well, this is tree number 2. So this is right here. It says positive, test negative. Well, if they tested positive, 423, and it says, what would you say to a friend regarding the validity? Like, how valid is their test? Well, 62 out of 423 or 361 out of 423. These are 2 ratios that we come up with, okay? From either of these branches to the main branch of tree number 2, all right? 62 out of 423 is approximately 15%. If we go with this, that would be 85%, right? Because 15 plus what is 100? That would be 15 plus 85. So that makes sense. Both of these make up the entire 423. So what does the 15% mean? The 15% means that there's a 15% chance you don't have TB if you test positive. A very small percentage. There's a chance, but there's a very small chance. Right? Testing is not 100% accurate. So somebody tests positive, oh my gosh, I got TB. Hey, if you don't think you do, you go back and get another test taken. Right? That's basically what that means. Question 9, in this situation, explain the consequences or errors. You do the best you can to fill that in. If you have questions on that, let me know. And question number 10, if a health test is not 100% certain, why might it be beneficial to have the results lean more towards a false positive? Meaning, false positive, meaning you tested positive even though you don't have TB, right? I don't have it, but I tested positive. That's a false positive. Well, think about it. If you don't have it, but you test positive and you take the medication, is it going to do any harm to you? Versus if you actually have it and you test negative and don't do anything about it, that could cause you a lot of health problems, right? Okay. And then the ready for more. We have a couple of those real quick that we're going to look at. And you can answer question number 2 on how these probabilities are different. So here's number 1. Find the probabilities using the tree diagram. So we're going to use our tree diagrams here, and we're going to use these to help us. All right. So question number 1. What's the probability that someone has TB and tested positive? All right. So there's that one. Probability of has TB given they test positive. All it's asking you to do is come up with that probability. All right? So test positive. So it's test positive, test negative, right? That's tree number 2. All right? So that's denominator is going to be 423. And has TB. Well, gee, has it. That's 361. So that's a pretty decent. Oh, no. Back up. Sorry. Mr. Wilson's got to read this here. That's not a given. Has TB and test positive. Oh, they're throwing one out there for us, okay? They're giving us an and we haven't seen any of these yet, right? What's the probability of have TB and test positive? All right, well, now we got to go back and we got to look at, okay? The and is almost like a slash too, like a divider thing, all right? Test positive. So now we go back to patient has or doesn't have, test positive, test negative. Which one is it? All right. Well, I have TB, so has TB and test positive. Well, again, this goes back to has or doesn't have. Okay, that would be a number over here, but and test positive. Well, this is what is a little bit tricky because it's all the people that tested. This and here includes everybody that tested, not given, it's and. So that's a little bit tricky. And then what's the probability of has TB? That's 380, okay? Or excuse me, 361. Not has TB, okay? Has TB and test positive. Okay? We got to make sure we test positive. All right, so that's 361. All right, and then that's the bell for class. So real quickly, the probability B changes a little bit. B is that probability is not correct. It's has TB given they test positive. All right, so this one changes a little bit. Now it's testing positive or negative. So this is where we're going to look at here because it's the given thing. So that's 423, and it says probability of has TB. Well, again, has it. So that's 361, right? We tested positive and we have it. You can't see that, but it's on my little sheet, my other graph over here, right here. Okay, it's on this one. Okay, tested positive, has TB. So that's 361. That's 85%. All they want to know is the percent. We don't have to explain it. They just want to know what that is. And then answer question 2. How are they different? How do they differ, rather? All right. So answer those questions the best you can. And I know this is confusing, all right? I really get that, okay? You just do the best you can with this material, all right? And an assignment will be posted as soon as we get some internet going.